you'll discover what's possible. So first things first, I think we should cover what a database is. The purpose of a database is to store data, and you, particularly when you're running applications in the cloud, you have no way to actually store data typically in a persistent way. So like I want to actually, let's say I'm running something in memory, like I collect some user data, I want to put it somewhere. A database is typically where you're going to put that. And so on that note, let's look at what kinds of databases exist. So a file system could be a database. It stores files. It's typically how we organize our stuff when we have our documents or games or other things on our computer. A library is also a database. It's a database of books. And if you think about how a library is organized, it's organized in a very particular way because you need to be able to find books. You can't just like throw a bunch of books in a room and say, okay, this is a library. Typically, you're going to organize them so that they're discoverable. And so what kinds of things could you put in a database? You could put medical records in a database. You could put money movements in a database. Could be messages from loved ones, McDonald's locations where the ice cream works. If you guys have ever seen this before, it's pretty funny. But yeah, so those are a couple of examples of things you could put in a database. And it's really, really important that you get your data stored right, because you could have data that's really important. And typically, especially if you're building a product or some kind of application that you really want other people to use, especially with I saw the theme of this hackathon was to try to build things that could be in the market, could endure in society. And if you want that, then you're typically going to care a lot about your data. And so you want to make sure that you get things correct, because data is like all you have. It's your facts. Like it's what you know about the world. It's like basically a compressed snapshot of reality at a point in time. And you're saying, okay, this is what this is today. Like you're saying, oh, a user's first name, email, last name, that's what this is today. And you don't want to get that wrong, or you don't want to miss data. And so something I've noticed being in the industry for a little bit now is that often most web developers, especially early on, you're so excited about writing application code that you forget that underneath it all, the thing that really matters is like what data that you have. And because that describes everything that you know about the world. And it's really easy to just kind of forget that you should care about your data first, but first and foremost, actually more than really anything else, because everything that's there is what you know. And it's basically like your knowledge base, right? And so, and people depend on it. That knowledge base being correct is what basically runs everything else. Like when you use any app that you can think of, that the fact that the app has information about you and knows certain things about you is why it works, and why it works the way that you want. So I would recommend not thinking of databases as like dummy data stores where you just put some data and then like forget about it. They are full-fledged applications, as I'll try to show throughout this presentation and throughout this workshop. So that said, let's get right into Postgres. So as you can see right here, the database that I'm going to be talking about today is called Postgres. And there are many other options for databases that you could choose. I personally like Postgres a lot. And so, and I also use it in production. So I'm going to be going through Postgres because it's the one that I know the best, and also my favorite. And so more about Postgres here, like what is Postgres? Postgres this is basically a description from Wikipedia. What you really need to know is it's free to use and it's open source. It's an application that can hold multiple databases. So I will often say that Postgres is a database, but that's actually not what it is. It's actually an application, just like any other program you run on your computer, and it can actually hold multiple databases. So whenever I say Postgres is a database, know that I actually mean it's an application that can hold databases. And when other people are saying that, it's also typically what they mean. Often when you're actually running something in production, you're going to have typically, maybe one or two databases, maybe a couple if you really want to, but your core production data is probably going to be in one database. And then you could maybe spin up multiple separate servers with other databases in them, but you're not going to have like too many databases usually in one specific server, at least when you're small. And so the most important thing to, I guess, contextualize what Postgres is it's a relational database management system. I'll get more into what that means and like what relational is. And SQL is or SQL as it's called, but most people usually say SQL, is the language that you use to talk to a database. So SQL is how you're going to communicate with the database and ask it questions and figure out, okay, like based on the data that I have here, I want to answer certain questions. I want to know something about like what's going on, or I want to put more data in there. Let me turn that off. Okay. So in Post or in SQL, typically you store data as rows and columns. And so, like for example, if you've seen a spreadsheet, you'll see how you have rows and columns. Database or like relational databases typically store data in a similar fashion. So it's just rows and columns. It's really not that complicated. You can do a lot of complicated things just with that, but the bare minimum that you need to understand is really not that complicated. And so today I'm going to be covering 5 operations. And you can consider these verbs or clauses. So we're going to go over like create, insert, select, update, delete. Create actually there's a lot of different things you can create. Today, we're going to just be covering tables and creating a database. And there's also, you can create like functions and other things, but we're not going to go over those today. And then the other 4 operations might look pretty familiar to you if you have at least some background in trying to develop development, or even if you're just getting started now and this is like the first time you've seen code. Hopefully this workshop should still be pretty intuitive. And you can pretty much understand what's happening based on the different words there. So like insert is putting data in the database, selecting is getting data out of the database, updating is like changing something that's already there, and then deleting, of course, is removing something. And so I have an appendix at the very end. I didn't mention this yet, but there's an appendix at the very end of that README that I have on GitHub, and it has links to like a bunch of different things. So feel free to look at that. That's definitely where I would go after this workshop. It's just like go through those and like, you know, learn, pick apart whatever you'd like, because I've just linked a bunch of different things. And thanks for saying in the chat. So with that said, let's get right into the code. This is where I guess the surprise comes in a moment here. So if you are following along, you can, again, also check out my GitHub in case I'm like going through the slides too fast. You can, it's all like copy pastable. So you can take whatever I have there and like run it locally. I would recommend running this inside of a P-SQL shell. Let me show you what that looks like. There might be different ways to open it depending on how you have your setup, but typically in like your start menu or in your terminal directly, you should have a way to open P-SQL. This is not a real command, by the way, that's just an alias that I have. It's typically PSQL. And so it'll open like a terminal like this. And every command that I'm running in here can be like copy pasted. So you could take this and just like put it in here. I've already ran this particular one. And so if I do it again, it's going to fail. But you can just type that in. And the semicolon is important. The semicolon is how SQL knows that a statement is ending. So make sure to put that in there. And yeah, okay. So let's keep on going here. So this is the first table we're going to look at. It's going to be called the users table. And I put this in here to indicate that SQL isn't case sensitive. So you can actually put things in any case you want. Everything will automatically be lowercase. And if you want something to be specifically in a certain case, you have to put double quotes around it. So for example, let's say instead of first name being snake cased here, and snake case meaning you use underscores to separate words. Instead of snake case, if you want to do a camel case, which is where you have first and then you make the N capitalized without this underscore here. If you want to do that, then you have to put quotes around first name. Otherwise, SQL will automatically lowercase it. So if you want to do anything in different casing, you have to use double quotes when referring to things like columns. And so before I get to that, let me talk a little bit about how this is actually set up here. What this syntax is doing is it's creating a table called users. And this first thing here, this is a column name. So ID would be a column name, first name, last name, email, password. The thing that comes right after the column name is what's called a data type. Postgres has many, many data types, everything from like IP addresses to UIDs to JSON to characters, like phonemic characters to auto incrementing numbers, which is what this is. So the serial is basically an integer, and every single time a new row is inserted, the number will automatically increment. So if the first one is 1, then the next one will be 2, and it'll do that automatically without you having to like specifically insert this value. Text is basically just anything, like any string. text is what I would recommend using if you know that it's not like any particular reference to another table or something. If it's just going to be some data that you want to put in one field, and it's not like a JSON or something like that, then text is the way to go. And so the other things after that are just specific. I don't know what the actual like technical term for this is, but there are other options you can pass into each particular column definition that you can inline right here. Like for example, this one I'm saying not null, which means that whenever I create a row that's like a user, I have to provide a last name. I cannot insert a user without providing a last name. That is this typically you probably want to make the first name not null and not this, but just for illustration. Like here, there's another thing called unique. This is saying for an email, you want to make sure that the emails are unique across the table. So if you have a users table with a bunch of emails, the database can enforce for you that the table or that there's no two rows in the database that have the same email. And typically like these are called constraints. So like this, for example, is called a primary key. Primary key means that primary key is basically how you uniquely identify a row in a table. So it's the way, like typically you want every table in the database to have a primary key. I really can't think of a reason why you wouldn't want a primary key on a table. So definitely make sure I have some kind of a primary key. I'll show you a different example of a primary key later, but primary keys are super important. They're how the database will typically uniquely identify a row amongst all of the other rows in the database for that table. Okay, so with that said, let's run it. One cool thing, so that I guess the surprise is that this presentation actually has executable code. So when I like hit the right arrow right now, it's actually going to run this against my database. And so that's also why I had to kind of set this up slightly beforehand. A lot of the code in my presentation will be executable, and it's, as soon as I hit the right arrow to go to the next slide, it will actually execute the code. So let's keep going. So the first thing we want to do is, okay, just going a little too much. So the first thing we want to do is actually insert some data. Without inserting data, there's nothing to really do after or before that or after that. So let's start with that. First thing to notice is the way we basically do it is you say insert into and then a table name, and then you pass in the columns you want to insert. Notice I don't have the ID column in here. And the reason is because, like I was saying, the ID column will basically be auto-generated. And so you don't need to insert that every single time manually. So you can just let the database handle that. And so I put each of the individual columns, then I say values, and then in the same order that I put these columns, I put these ones. So first name, last name, email, and password. And then returning star is not necessary. That's just syntax that you can't actually use in every SQL database. I don't think it's a Postgres specific thing, but not all of them can do this. And if you do returning star, what that basically means is you're saying, give me all the data back that I just inserted, so like show it to me. Because by default, what Postgres will do is, or what most SQL databases will do is they'll insert the row and they'll tell you that they inserted the row, but it won't show you the data that it inserted. So I'm just doing this visually so you can see it. And also, yeah, white space doesn't matter. So like, it doesn't really matter if you put an enter like right here, put another like tab right here or something. Postgres will figure it out. So here's what it looks like when the two rows are inserted. So I have two insert statements. I've run both of them, and this is now what it looks like. So like I was saying, this is the actual output from PSQL. I'm just showing it directly in my presentation as it's running. So you see how the ID column was inserted. Now this one is 1, this one is 2, and you can see to the first name, last name, email, and password. And this is the thing I was just mentioning with returning star, not needing to be in the query. Okay, so one thing I want to mention really quick, never ever store passwords in plain text like I just did on the last slide. Typically you will want to, even if you don't know what these terms mean, I would highly suggest looking them up. You want to make sure that your passwords are always typically what's called salted and hashed. You don't ever want to just like put someone's password directly in the database. And so, because you don't want to be able to look at the database and know what someone's password is just by looking at it. So there's definitely ways to do this. Pretty much every language has libraries for doing this. This is definitely really important to do. and do not store passwords in plain text. If anyone were to ever hack you, they would just be able to grab every user's password, and you do not want that. Okay, so let's get into actually getting that data out that we just put in. The syntax for this is basically select something from something. So the star, usually you can replace this with the column name. So you can say like select ID, comma, first name, comma, last name from table name. It can get a lot more complicated in this, but for now, let's just say you can only use a table name. You can actually put a lot of other things here too. But for now, let's just say you're going to put a table name in there. It'll look like this. So you might remember from the last slide, we had 2 rows that we inserted, and you'll see the 2 users here with ID 1 and 2, and both of them show up here. And so let's do update. Update is a kind of, not too complicated. It's like fairly straightforward syntax. So let's update the user's first name. Oh, wait, we just updated both users. When we probably typically are not going to update every single user's first name. We're probably looking to update one user's first name. And so notice how like both of these first names have now changed, and we don't want that. And so this reminds me, this is how I feel right now. By the way, the reason I had to do this is because I couldn't get this to actually show up in the terminal. But anyways, so the way you do this, the way you say, okay, I only want to apply this particular operation to a subset of rows, not every single row, is using the where clause. The where clause is super, super important. People make this mistake all the time in production, no matter how experienced you are, it happens. Like someone will run like update something, set whatever, and then don't put the where clause, and it updates every single row. Like we literally had this happen in production maybe like a few weeks ago, and I have to fix stuff manually. And it's not fun. So definitely make sure to put a where clause whenever you do update or delete statements, which we'll get to in a second. But you definitely do not want to delete every row in the database. So don't ever use a delete clause without using a where clause. So let's try the where clause this time with select. So I only want the first row. And so now I've only gotten back the first row. I didn't, as you saw a few slides ago, we had both rows come back, and now only one row comes back. And so I'm uniquely identifying it by saying, okay, there's an ID, ID equals 1. And you can put a bunch of other conditions here. Basically anything that's after the where clause just needs to evaluate to some kind of Boolean. So you just say like, you could say ID equal 1 and first name equals this, or and email equals this. And so that's really all that matters, is that whatever comes after the where clause just evaluates some kind of Boolean expression. And and also another thing, if you've never done like raw SQL before, you'll notice how I only use a single equal sign. Typically in SQL, you are going to use single equal signs, not double equal signs, like or triple equal signs in certain languages. You're just going to say, when you want to say when something is, check where something is equal to this, you just say equal, not like equal, equal. Okay, so let's keep going. Let's update only the first user this time. So I'm going to change it to my name. This just ran against my database. That's why it's showing that. Notice I didn't put returning star, so I just see like update 1. It doesn't tell me what I did. And then let's delete that person now. So now that person's deleted. And this comes back to what I was saying earlier, never, ever, ever delete without a where clause. If you actually want to do that, if your goal is to delete data from a table, just make sure to use truncate, and that will actually just clear the table. And if you want to get rid of the table altogether, you can use drop table. But again, you're typically not going to do these things unless you're changing your data schema in a pretty important way. Then you might want to drop tables or like data around before you drop a table, or even create a temporary table for moving some data around. And so that's totally a possibility. And so ignore the create extension part. I'll come back to that in a little bit. But the reason I'm using, or actually, maybe this is important. This is important because in Postgres, you can have, Postgres has a way of like creating plugins basically. And PG Crypto is, I would say like a built-in extension. It pretty much comes with every installation of Postgres. It gives you access to certain functions that you don't get by default. And so that's the reason why I have that there. If I use PG Crypto, then I can generate what are called UIDs. I don't know if everyone's heard of UIDs, but they're pretty commonly used for generating like basically random identifiers. Let me actually show you a quick example, maybe of what one looks like. If you've never seen it before. So UID might look something like this. So it typically looks like this. It's just like it's a very particular string that's in this shape. So you'll see most of them look like this. But every single time you run this, the characters that are generated are supposed to be different. So it's just like a unique identifier. And so you can have Postgres generate one of these for you. So you saw before we used to use an integer, and now we're using a UID instead. The reason I use a UID is because if you're using the integer, then for example, the books table could have a 1, 2, and a 3, and then the users table could also have a 1, 2, and a 3. So if your front end is typically pulling data directly from your backend, which is directly from your database, then you might not be able to easily uniquely identify certain rows just based on their ID. But if you're using a UID, then you can guarantee that every single time it's being used, it's going to be a unique type of string. Oh, and then yeah, as you guys saw before, there's a few new things in here, but there's a couple things that are still the same. Like the primary key is still the same. This is new, so I'm saying like use basically default to using this function. Like if I don't pass in the ID column when I'm inserting a book, just use this function to create it. That's basically what that's saying. We have this new thing in here though. This particular piece of or this particular constraint. This is called a foreign key. So this is how you do references. If you've ever done anything with spreadsheets, you know, you can, rather than copying the same data over and over again, you can say like, oh, in column A3, I want to take A3 to A20 and I want to sum up all the rows. And so you typically, when you have data, you don't want to copy it over and over again. You just want to refer to the original source. And so let's say that in this example, what this is basically saying is a user is tied to a book. And this is not how you should design it. We'll come back to that in a second, but just to illustrate how this works, I'm saying, okay, I'm going to give you a user ID. It's going to be an integer, but it's actually a reference to a user. So Postgres can know that. Postgres can do two things about this. One is underneath the hood, it can do certain optimizations when you're doing queries because it knows there's a relationship. And this is part of the relational aspect is your data has relationships. So you want to encode that there is a relationship between these two things. And the other thing that it can do is whenever you insert a book and you insert a user ID, it can validate that user ID that you're putting there is actually a user. Like it'll actually go check in the users table to make sure that this user ID that you're inserting is actually a real user. Because if that ID doesn't exist, that means you inserted something wrong, which by the way, without foreign keys, this can happen all the time. And it's really, really good for catching bugs because you might accidentally try to insert an ID that's not even a user, is not even related to this table. And you don't want that to happen. It causes your data to get really messed up. So it's really helpful for catching bugs, and that could be possible in your application code. And so as far as the book table, we're just going to have something simple, ID, the user ID, and then the title and the subtitle. So now I created that table. I already kind of describe what foreign keys are. So I can just kind of skip to this part, except for this. I think this is a little important to mention too. There's a specific term that actually describes separating out data like this. It's called normalization. So you're saying, okay, I have this unique piece of data. I want to put it in its own table and not like duplicate the same information across multiple tables. There's something called a normal form, and like first normal form, second, third, fourth. I think it goes all the way to 6, but I think only like third and fourth normal form are how far you typically go before you stop. There's more links in my appendix that describe what the rules are for this. Okay, so let's now interact with the books table. Notice that again, we're not actually inserting the ID. It's going to take care of it for us. Let's try this. Oop, there's an error. So you'll notice how we forgot to put in the title. This comes back to what I was saying before. If you define your constraints correctly in the database, it can catch you when you're making mistakes. And so the database is now caught that, hey, you said there was going to be a title, but you didn't give me a title. So make sure that next time you do this, give me a title. And so it'll tell you what the row that you inserted was. Notice how there's a UID here, and then I inserted 1 for the user ID, but there's no title. And there's supposed to be a title in this column here, but we didn't insert it. So getting your constraints correct is important. You're not always going to obviously know everything about what you're doing the moment you start. So that's why it's important to get your constraints correct to the degree that you can when you get started. And then learn the SQL commands that you need to evolve your requirements as you go along. And it just prevents you from making mistakes at the outset. And it also makes it easier for anyone looking at your database. So if someone else is trying to understand how your data is structured, when you have clear table definitions, other people can look at your database, and without you having to necessarily document every single thing, it becomes fairly clear, especially in SQL, because it's like pretty declarative and fairly straightforward what things are. Someone can just look at your database and say, okay, this thing ties to this. If the column names are descriptive and the references are there, it makes it easier to understand how to do stuff. And this is helpful not just for the technical folks on our team, but if people are doing like data analytics and they're not necessarily, they don't have like a programming background, it also helps them figure out how to get stuff out of the database when they want to ask good important questions. Oh yeah, and this too, like it's when you go to production, users will find every single way humanly possible to break your application. Like it's amazing how many things that you think are never going to happen that will literally be the first thing that happens. We've had multiple cases where we have shipped something to production. We've told each other, we've been like, oh, this is never going to happen. And it's the first thing that happens. The first user that does something breaks that exact thing. So having constraints well defined is really helpful for catching these kinds of things. So let's insert a row into the books table. This is the first time we're actually using a foreign key. We will do basically what we did before. Again, it's the same syntax, nothing really complicated here. I'm not inserting the ID, I just need the user ID and the title, because those are the constraints that we defined. Because we didn't say subtitle was required, so we only need the user ID and the title. So let's do, sorry. Just want to make sure I have the chat window open. Okay. I'll answer that question in just a second. But okay, so let's insert this. Is that even showing up? Oh, oops. Let me see what's going on here. So I guess part of being a workshop is that we should debug this stuff in real time. Let's see what's going on. Something I also didn't mention. Sorry, this is my mistake. If you're connecting, if you just open PSQL, it'll take you to this prompt where it says Postgres. This is actually the like the root database. If you created the database using Create Database Explorer Hacks, you actually want to use /c Explorer Hacks 2021 to actually connect to that database. And that's how you can make sure that you're in that particular database. The commands that you saw on slides may have worked anyways, but typically you don't want to write stuff directly to the root database. You want to write it to whatever custom database you're creating. Let's see what's going on here. Yes. Okay, I deleted that user. I forgot about that. Okay, so how about we reinsert that user again? Give me 1 second here. So let's reinsert that user. And I'm actually going to insert the ID manually this time, so I can verify that it exists. Oh, let's change it now. Let's change it to, let's change that. Okay, cool. So, and actually we just ran into exactly what I was talking about before, which is I tried to insert a book without a user, and the database stopped me. It said, you cannot insert, this user ID that you're trying to insert doesn't exist. And so this is super helpful. Like basically what happened just now is exactly what I was describing. And that was not intentional, by the way. So that's exactly what's super helpful. Okay, I think so now let's see. Oh, okay. I'm not sure why it's showing up, but it should look like this. Basically what we just inserted. Let me keep going. Oops. Okay. So let's think about what our database looks like so far. We have a user and a book. And whenever books are inserted, it's tied to a user. That doesn't really make sense though, if you think about it. Why would you want to have only one book, or like, why would you only have a book tied to only one user? We typically don't want that. If you're, let's say you're going to a library and I'm a user of the library, I would want to be able to check out multiple books. And so the relationship that we define is wrong. And so how do we address that? There are several ways that you can typically have relationships between tables. I guess these are the canonical ones or the common ones. So you have like a one-to-one, which is what we just did, where you say like one user, one book. There's a one-to-many, and many to one-to-many are kind of the same thing. It's just that the arrows are in a slightly different direction. So let's say you could have like a user with many books, or books, or like just books with many users, and that relationship only goes in one way. And then there's many to many, which means it goes both ways. So like a user could have multiple books, and a like, books could have many users, which is actually the relationship we technically want. It's a many to many, where you say like, okay, I can have multiple books. And so let's look at how we actually do that in SQL. This is typically done with what's called a junction table. And so you might have a table like this, where you have like a user's books. Typically, the convention is you take the two tables that you're trying to join together effectively, and just put an underscore between them. So it's like users underscore books. And notice here how we have basically this table only contains two foreign keys, and then it has this new syntax that we've never seen before, but you're defining a primary key across multiple columns. And so it's actually possible to do this. You don't have to define a primary key on one column. You can say, I want these two columns together to be unique. And you can actually have more in here, but so in this case, I'm saying any user ID book ID pair has to be unique. And so you could have the same user ID with multiple books. That won't violate this constraint. And I'll show you how to use this in a second, but this is typically how you're going to define a table like this. That's only purpose is to just put two tables together, or I could put a relationship together between two tables. This particular syntax for like using multiple columns to define a key is called a composite key. And okay, so now we've done that, now we've created that table. Let's now insert a row into the users books table. So first things first, we want to get a user ID. We already know that we have a user ID that's 1. And then notice here, I'm doing something kind of interesting. I didn't just like put in a hard-coded value. In SQL, there's this concept of subqueries. You can do subqueries in a lot of different ways to write really, really complicated queries that are technically only one statement. You can have like one example is we have a query that we use for some analysts. It's like a 100-line SQL query, but it's only one query. It just has a bunch of subqueries within it. And so here, what we're doing is we're saying, before you insert this row, get me a book, just get me one book. So this limit keyword is just saying, get me an ID from the book table, and just give me one, like give me one row back. So if I remove the limit one, it would give me every single row, which would be invalid because I only want to return a single value basically. And so the way I return a single value is I say select ID, and I say give me only one row back, and that'll give me just one ID. And so now I can insert a relationship between the user with ID 1 and whatever the first book is. And so it'll look like this. And so now we have, again, this code is actually executed in the database just now. You have the user ID and the book ID. And so now we know which users have which books and vice versa. And the way that you actually put the two together, like to say like, okay, how do I actually get the data out so that I know the actual user information? Like this isn't super useful because I still need to know who the actual user is. I want their name or the book. I want to know what the title is. Just looking at this doesn't really help you. So you need a way to actually put the two things together and say, okay, I have the relationship now. Now I need to get the data out. Unfortunately, joins are pretty complicated. It's a very powerful tool in SQL, but there's several different types of joins. It's pretty complex to go through all of them. So I'll just give a small taste of this, and then I think the best way to learn how to do joins is really honestly just to write a lot of them, and you get more used to the syntax. And so basically what I'm doing here is I'm saying, get me the user ID, the first name of the user. And so notice this U here, that's just like an alias. So instead of having to type users out every single time, I can just use the U as an alias. I can say u.id, u.first name. You can also use the as keyword to alias a particular column. So you can say, I want the first name. Instead of, you guys might have seen in the previous queries that we've run, whenever you query out a column, it just shows the column at the top, but I want the column to show up like this instead. So it looks more human readable, and you can do that by using the as keyword. And the join here is the, I guess, newest thing. And what I'm doing here is I'm saying, okay, I have a user. I want to join on the users books table. So basically you can think of it like concatenating a string, where I'm saying like, I want to take the users and I want to like just mash that table together with the users books table. And the way that I know how to like put them together is I use this join condition. And I'm saying, I want to take the user ID and then grab the user ID from the users books table. So like wherever you see wherever those two match, or wherever you can put the two together, give me only basically those rows back. When you use a join without any, there's also other types of joins, but the simple type of join we're doing here is basically saying wherever there is a user's book or users books with user ID, just give me those ones back and match the two tables together. So you get all of the columns back. And same with the books ones. Now I've gone from users to users books. Now I need to get the books. So the way I do that is I now join on the books and I say from users books, there's a book ID and there is a ID on the book, and just put those together. And so now I effectively have all of these columns from all of these three tables accessible to me. And I just pull apart the ones that I need. So if I do this, you'll see that we only inserted one user's books, or I'll just say user book, but we only inserted one of those. So I only get one row back because I only inserted one relationship there in that junction table. So I'm getting back the user ID, the first name, and then the book title. Okay, so you may remember we used to have, or we still have a user ID column on the book table. That shouldn't exist anymore. So let's just get rid of that one. Typically, if you did what we were about to, like what we just did in the past couple of minutes in production, you'd want to make sure you're migrating the data over. So like you don't want to just like drop the column first. You actually want to do a migration to grab all the data from the books, like probably create that new junction table, insert, like backfill the data, and then delete this. But this is roughly the process to clean up and deal with whatever you did before that you realized was wrong. So as I was mentioning, that also just ran against the database. And okay, so with that said, I've shown you some of the basics of a couple of things you can do. And I just want to go through a quick list of just a lot of different things you can do. And then I'd like to show you more. I'll answer this question in the chat, and then I'll also go through a couple more visual examples because we've just been looking mostly at slides and a little bit of data on the slides, but I want to show you guys like visually what's possible. And I think it'll be a lot more exciting too. So one thing that Postgres can do is it can handle JSON natively. So, and what I mean by that is that you can do a variety of different operations on it. So you can query JSON, you can update it, you can index on it, you can even do joins across. Like let's say you typically shouldn't do this, but if you have a table with a JSON field in it, and there's like a giant JSON object you have, then you can actually take a different table that has a reference to that table and do a join between them inside of the JSON. You can do like pretty complicated things. You can turn rows into JSON. So for example, like the rows that we've been doing where we do select star from users, instead of doing select star from users, if I said there's other SQL functions you can use to say I want to get back all the rows as JSON. Let me actually see if I can do that really quick. So one example of this could be, I think this is correct. Oh, that's not it. Yeah, I don't remember what it is off the top of my head, but let's just do maybe a single row. Yeah, typically I just look at the docs because honestly it's kind of hard to remember what some of these are. Okay, I don't remember what it is, but there are several different JSON functions to do operations of various kinds to turn typical like relational row and column data into JSON, and you can even construct like custom JSON objects, all that kind of stuff. So there's quite a bit of JSON support in Postgres. Honestly, like in some ways probably better than Mongo itself, even though Mongo's native data structure is effectively a JSON object. And yeah, so there's that. And then as I was saying earlier, much earlier in this presentation, there's dozens of data types, everything from like IP addresses to geospatial stuff, which I'll show you guys in a second. It's pretty cool what you can do natively in Postgres, which before a couple months ago, I actually didn't even know some of this was possible directly in Postgres, because you'd think like, oh, I'm just going to use Google Maps or something, or use the Google Maps API. You'd be surprised how much you can do directly inside of the database. You can extend functionality via extensions, like I was mentioning before. There's that one extension we use called PG Crypto, but there's many other extensions that do a lot of different things, and people are free to extend Postgres however they like, or at least to pretty, I guess, significant degree. You can change Postgres to do things that you think it couldn't typically do. Everything from being able to scale horizontally or like write extensions to distribute Postgres across multiple like, servers to there's a one thing called a foreign data wrapper, which you can use to actually talk to other databases. So you can actually interface with like Mongo or MySQL from Postgres and treat it like a table inside of your database or Redis and say, I want to query this like SQL, but it'll actually give me back data from an external data source. There's other cool things you can do like that. Oh, and one thing I also didn't mention, we didn't talk about creating functions today, but you can actually write code directly in Postgres. There's a language that comes with Postgres called PLPD SQL, which can be used to write more, I guess, typical programming style programs where you have like, if condition or a loop or something. You can do some of those things with PLPD SQL, but you can also write Python inside of Postgres. You can also write like JavaScript. There's a way, there's someone that wrote a way to basically get the V8 engine that you usually use to run Node inside of Postgres. And so you can actually execute JavaScript directly inside of Postgres. You can create a function that runs JavaScript if you enable that extension. And people actually use that in production. And most of the major cloud providers support this. There's also extensions for like doing time series data and some other things too. But yeah, we'll talk about Postgres in a second, which is basically the way the de facto way of doing geospatial stuff in Postgres, probably one of the coolest and most powerful things that I've seen a database be able to do. And then there's some other things that we didn't really talk about that aren't super important if you're just kind of building an application for fun. But when you're using stuff in production, is incredibly important, like having what's called transactions. So you can take a series of SQL statements. Let's say we're doing like 5 insert statements, and we want to make sure that every single one ran or none of them should run. And Postgres has a built-in way to do this, or SQL in general typically has a built-in way to do this using 2 keywords called begin and commit. So you start the transaction by writing begin semicolon, and then you run all the like SQL statements that you want, and then you put commit. And if like any of those fail, basically everything will be rolled back. And that's super, super powerful because you don't want to like partially insert data and then like miss something. Like let's say, for example, we're inserting a user and then we want to insert like some books, and then we want to insert the user books, and we want to insert like all 3 without missing any. And if we didn't have transactions, then what could happen is that you might insert the user but not insert the other 2. And that, depending on what you're doing, that could be a problem. So transactions are super valuable. And then I won't explain necessarily what this means. This basically high level is just saying, like MVCC just basically means I need a way to, when I'm writing data to the database, like let's say that one server is talking to the database and is trying to write stuff to it. You don't want to prevent another server that might be talking to the same database from reading stuff out. So if you're running something in a transaction, Postgres can actually almost isolate each of the 2 servers. And so you can say, for example, let's say I'm inserting like 5 books and I'm not done yet, and some other client somewhere, some other server is trying to access that same database and read the books. Postgres can actually make sure that if this transaction is yet to complete, that other computer that's trying to read the database can still pull out the books without this one being done yet. And only when this transaction finishes can that other one actually access those new books that were inserted. It's kind of hard to explain without a diagram. I don't know if that makes sense, but high level, it's just a way to prevent anything from being blocked when like multiple servers are trying to do stuff to the database. And oh yeah, there's also like a bunch of other cool things with permissions that we also didn't get to talk about today. Everything from how you actually separate out concerns and you can create permissions in a really granular way where you can say, I only want to allow this kind of user to select these particular columns from this table. You can go pretty granular. You can also say, like, I only want to return these rows if you have a certain user ID and things like that. So it's pretty sophisticated. And I think another cool advantage too of, I guess, just using a Postgres database is there's a lot of cool tools now in the past couple of years that have come out, which let you do stuff on top of Postgres. So like PostgreSQL is something I've used before. It's really good for prototyping. If I was doing a hackathon, I'd totally use it. Assuming I knew something about GraphQL, I think it speeds up the development process like insanely, because you can just say, okay, create some tables, and then PostgreSQL can effectively take all of your tables, your functions, and whatever else you've created in the database and generate an API on top of them without you needing to necessarily worry about a lot of the other details. And if you have anything that, of course, not everything you're going to do is tied to the database, and there's other functionality that it has to be able to say, okay, I want to create like a job that I can later run through some kind of worker in the application layer. So like I want to send an email, for example. You're probably not going to do that through the database, and you're going to do that through some like application code. And so you wouldn't do everything through the database, but it speeds up a lot of stuff. Okay. Like I was saying, there's so much stuff in Postgres. The documentation is just the documentation is good, and there's a lot of stuff, and it's kind of amazing just how much stuff has been thought through. And so again, my favorite database, I could not really see using any other database at this point in production unless I needed to build a very custom solution for a very specific problem. If you're doing like most of the things that most people typically are going to build in terms of software is, I think, uh, solved by Postgres in a lot of ways in terms of the data side. But of course, you may be building something really new, and you might actually not even want to use a standard off-the-shelf database, but that's not super common. Oh, one other thing I'll mention too is typically the way you keep making changes to the database is with something called a migration. And if you've done any like web development, you may have done this with like an ORM or something that like usually generates migrations for you. At my company, we actually write the migrations by hand. This is something that I've learned from other companies too, which is generating migrations is usually not a very good idea because the tools can't like to know exactly how to change your database. You kind of need an AI because it's like, okay, I have this table now; it's completely changed. Maybe I'm like moving to this other table. Maybe I have like these two tables in between. It can't do everything for you. It's honestly just much easier if you like learn some SQL and then learn how to write them. And then you can use you can use some kind of migration system to or migration library to track your migrations and say, okay, here's the change that I started with, here are the new changes that I made, and then you can make sure that you're not accidentally doing something that you shouldn't be. But what we did today is basically part of a migration. We like started with a set of tables, and then we like made changes to it. And so there's more examples that I have in the appendix for how you can do this. And okay, so before I go to the questions, or sorry, before I go to the other piece of the demo I want to do really quick, let me answer this question. So typically, so I guess I kind of answered this question, like, should I be sequential? It depends. In our databases in production, we always use UIDs. So like you were saying, you can't just use like a random number and get to a certain piece of data. I guess it kind of depends on how you structured it, but it seems like, especially with modern tools that most people use, like GraphQL and whatnot, when you need the front end to actually be able to uniquely identify pieces of data by their ID, it's much easier to just make everything a UID. Okay, let me answer this other question. So the question is, which SQL database would you recommend if we were to go professional in what we're doing? I think nowadays Postgres has become, I don't know if I'd say the de facto, but a lot of people, if they're starting new, are typically starting with Postgres. There's just so much functionality that's been built. So Postgres has existed for a long time, actually. It's been around since like, I think around the time I was born, like back in like 98 or something. Like it's been around for a while. But it didn't really get super popular, I think, until the past 10 years. People started using Postgres more. A lot more like software and extensions were written for it that made it way more powerful than it used to be. So I think Postgres is something Postgres is what we use in production. I would totally recommend using in production. You can find huge companies that are using it for a variety of different use cases. Everyone from Microsoft to Algolia to like Braintree uses Postgres and manages like I think like I don't know, hundreds of terabytes of data, I think, with Postgres. So you can do a lot with Postgres, and it can be a little hard to scale compared to other solutions. Like for example, MongoDB is often thought to be very scalable because you don't actually define your data schemas and there's no relationships. So you just like scale outward because it doesn't, like you don't like really, I guess, care about what's in it. But I think that's kind of a fallacy, and you should care about what data you have and you should care about your relationships. It makes it much harder to know like when your data is wrong if you don't have any, like if you don't know what your data schema is, or like at least you pretend to you don't know what your data schema is, but you always do, because how are you going to put stuff in the database without knowing what's there? So I would highly recommend, again, if you're just getting started, give Postgres a shot, or any SQL database. But I think Postgres probably has the most features out of all of them, even compared to MySQL. So Postgres sharding is an interesting thing. There's a couple of kinds of sharding. Currently, like to actually even need sharding, you have to get your company has to get big enough to a point where it really matters. And honestly, most companies never even reach that size. Like you can get really, really far just by having one database that's vertically scaling, that has like a lot of CPU and RAM and whatnot. And then there are ways to do sharding in slightly different ways, whether it's saying, okay, I have like a way to uniquely identify a column. There's some built-in ways, and there's also some extensions that I think people are starting to rely on more and more. There's one called Citus that Microsoft bought. And so if you happen to deploy on Azure, you can use Citus to basically handle that for you and handle the horizontal scaling and the sharding and like doing the queries across multiple like Postgres nodes and all that stuff for you. But it's not a topic that I knew too much about because we actually haven't, like, we're not even close to the size where we as a company would need to do that. Typically what you would do is you're going to have like one database that's like the primary database where you do all of your reads and writes and everything. And you can have like what's called a read replica. So you just take all of the data that's being entered into one database and you can have it without you having to do any additional work, just stream to another database. And that database can be used for reads. So if you're going to be querying a lot from your database, you can, that's like one, I wouldn't call it a hack, but it's like one way to get more performance out of your database without needing to like actually do real sharding and like set up stuff in a more distributed manner. But that is one of the, that can be one of the more pain points, or like one of the pain points of SQL as you like get really big is needing to actually figure out how you can distribute data so your database performance is still good. But it's much, I think it's much better in the outset to get the data right than to be really fast. Because if that stuff is really bad in the beginning, then as you get bigger and bigger, the problems just get exponentially worse. So yeah. Cool. Okay. So I want to show a few things. I think first I will show you, oh, actually, okay, so it's kind of shows up a little weird on the slide, but this is an example of PostGIS in action. So these functions here are from the PostGIS extension or PostGIS. So GIS is, I think, like geographic information systems or something. That's like a whole subfield of people who are really interested in geography. And there's also some standards around it. Post is just Postgres, of course. And so PostGIS is an extension on top of Postgres that gives it geospatial capabilities. So you can give it, for example, like latitudes and longitudes and say, it has custom data types just to handle geographies and doing like mathematical operations on geography or like specific points or like spaces and things like that. So you can say like, oh, I want a rectangle like a bounding box around this particular, like a polygon around a particular place. Or I want to, I'll actually show what this query is doing. So this one, is here. So this one takes, I've already ran the query, but basically what I'm doing is you notice I have this column called geom. And these are actually what's in PostGIS, it's called the geometry type. It takes a latitude and longitude, or I think it's a longitude and latitude in this case, and it creates what's called a point. So you'll notice if I click on this, in most sophisticated DB tools, like this one's called dbeaver that I'm using, you can actually view the data on map. So I can actually, for example, if I click on this, you'll see that it's actually showing the data that I'm, because like I might not know just from the dot which piece of data I'm referring to. So most tools will actually have a way for you to like visualize this. And if I drag most of them, or if I drag multiple, you'll see how they now show up on the map. And I have more options for this too, in dbeaver at least. Typically, you'll see pgadmin, which is like the de facto tool that comes with Postgres. I kind of like dbeaver more for some things, but in pgadmin, it's just OpenStreetMap, but dbeaver actually has the option to do other things too. So I can do like Mapbox, which might be a little easier to see because it shows me like better street names and stuff. Or if you want to go really cool, you can use Cosmo, which shows you satellite data. And so you can see like, and by the way, like note that this is in my database. Like I'm not, aside from the fact that this is making an API call to, whatever tool it's using to render the data, like this data is in my database and it's able to actually do queries on this. And I haven't yet explained what this query does. So let me get to that in a second. So you'll notice now when I click on these dots, it'll show me like which row that I'm talking about. And so you'll notice fun mode is right here. Bling was the one I just clicked on. And this is also, these aren't like real names, by the way, as you can tell. It's not like a real place, but it is a real address. So you'll notice that I'm actually in Arizona in the United States. I keep going out. These are different. These Mapbox. Yeah, you'll see I'm in the state of Arizona. That's where I'm from. And you'll see these are actual addresses on the map. And so what this query is doing is, I'd be actually very curious if anyone figures out what this latitude longitude is. This is the Phoenix Sun Stadium. So I'm saying, given the Phoenix Sun Stadium, find me the 10 nearest properties that are located to the Phoenix Sun Stadium. And this is directly natively in Postgres because I already know the addresses of the properties and they're in my database stored in this particular way. So I can actually query the database and ask it, give me the 10 nearest properties from where I am currently. In this case, this is the Phoenix Sun Stadium. So you're getting those the 10 nearest properties here, and that's how you can do like location-based queries and geospatial queries directly in the database. And you can, if you enable some other extensions, I think most cloud providers do support those as well. If you're running like a managed database solution, you can even do things like routing, which there's an example that I have in my appendix where some guy basically did like Google Maps routing, but in the database. So like he'll do kind of the view that you see on Google Maps where you can say like, oh, from here to here, calculate a route for me. He did that in the database and like renders it in the UI. It's pretty cool. So that's one thing I want to show. Another tool, let me just close this. Another tool is called Metabase. We use this in production as well. I'm just running it here, so I just want to show you guys what's happening. I'm just running this locally right now. It takes a second to start up, so I'll let it start up here, and then I can show you guys what it looks like. So just to give some context, Metabase is a tool that you can use to do like visualizations and stuff against your database. It's also handy for people that on your team that maybe aren't, aren't programmers, but they want to be able to look at your data and make insights off it. For example, like how many users did we get today? Or like they want to see some kind of time series data. They want to say, okay, how many properties did we onboard this month or whatever they're looking for. They can try to query the database for it and actually visualize it somewhere. So let me go to my browser here. Move this over. Okay, so this is just running again. I said, like I was saying, it's running locally. Metabase is a Java application, but it's actually written in a language called Clojure, which is a variant of Lisp, but it compiles down to Java bytecode. So here, let's look at the sample data set really quick. This is the one that Metabase just provides, so you can get a feel for what it's like. So if you were to click on one of these, you'll see this is like a sample data set where there's just a couple of different columns and it shows some information here. There's a built-in feature called X-ray where I didn't generate any of this. Like I don't have to create these dashboards. It'll just show me some information about my data. I'm actually not sure how they're doing this or how they're deciding what's important. But from the sample database, you can see like what's possible here and like all the different visualization tools available to you in Metabase. The way you create questions is you basically do this and you say, you can either do any of these. So simple one, if it's like a really basic, you can use the one that we were just doing. So if I want to do this, these are the rows that we inserted. You can do filters. And then once you actually get the data, you can visualize it. Depending on the data that you return, Metabase will intelligently know which one of these you can use. But looks like I'm about to run out of time here. So yeah, I just want to touch on that really quick, but you can create like trend lines and, maps and other stuff that I think several of which we use currently for our data. And so you can just query out your tables and do what you need to do. And it has like I was saying, it has a query builder that can help with some more basic stuff. When you need to write like really complicated queries, this is not the way to go. You should write your own query, but it can actually even show you what the SQL is. So I'll show you what SQL that it ran. Yep. Okay. That's right at 12 o'clock. That's what I wanted to go over today. Oh yeah, this is the final thing. So I'm going to drop the database now, and that's basically the end. And oh yeah, so the appendix. So yeah, feel free to go through that. I won't like click through all these, but I have a bunch of stuff at the end of my presentation, so definitely check that out. Any other questions?
You guys can put your questions in the chat or unmute yourselves and ask them. Also, Leo sent out the attendance form, so if you want to own extra points, then be sure to fill that out. Oh yeah, and there's also a questionnaire with questions about the workshop.
Yeah, feel free to ask anything. It doesn't have to be about in this presentation. If it's like anything Postgres related or database related, or how should I do something in production or whatever. Feel free. Or if you were curious how we do something in production.
Yeah, I guess if we have no questions, we can end it here. Oh, no.
Talking of databases. Yeah, this is, I should have mentioned this too, probably. This is really important. You definitely want to back up your database. In case anything ever happens, someone accidentally drops something or someone accidentally deletes data while like typically you want to avoid editing your database manually, but frankly, when you're a small company, we're a really small startup. Um, and it's like we just haven't built all the functionality in our UI yet to be able to do everything. So it's really common to like directly end up editing the database, just to like do certain things that we don't have as features yet in the UI, and um, just to like in the case that someone makes a really bad mistake, which thankfully hasn't happened yet. We've had like some small issues, like I was saying, where someone updates every row in a table, but like it's usually something that is then fixable later. It hasn't been anything like it hasn't been anything major yet. So the way you can do this in a couple of different ways. Typically, I've mentioned cloud providers a few times. I haven't really explained what that means, but let's say you're using like AWS or GCP or Azure or something, and you're using one of their managed database solutions. They're often going to have backup tools that are available without you having to set it up, or you're gonna have to set it up on their system, but you don't have to like manually do the like, backups yourself. You can do recurring backups. You can say, I want to back up every, I don't know, 6 hours, back up every day. Sometimes I feel like even though like we have backups, I feel like sometimes they're not enough because like so much can happen in a day. It's just hard to say like where you draw the line. You might want to do backups like every couple hours if you're seeing a large volume of data, maybe every day if it's just like a smaller project and you don't care too much. Um, but yeah, so typically you can do it directly from there. If you want to do backups locally, I don't know if I linked this in my appendix, but um, if you want to dump the database, there's a tool called pg_dump, and that will help you get the data out of your database in a format, either in SQL format or like a custom binary format that that's like smaller and that you can easily restore. And then pg_restore, the other, I guess, analog to pg_dump. pg_restore is what you use to restore that data. Let's say you're like taking a production database dump and then you want to store it locally. That's one way to do it. But yeah, typically underneath the hood, most of these tools in the cloud are often using something like pg_dump to just like back up the database periodically. And then also we'll have a way to restore it. Sometimes, for example, like in our system, when we restore a backup, it doesn't just like overwrite the existing database. It like puts it in a separate database that you can then choose to, I guess, you can either choose to drop the original database or to like migrate data specifically over if you need to. And so depending on your system, the way that you actually restore the data might be a little bit different. Oracle SQL. So the question was, just in case anyone can't see the chat, and if you're on video, you probably can't see it. The question was, what are thoughts on Oracle SQL? I've never used it. The only times that I've seen people use Oracle SQL are usually in huge enterprise companies where they have just been using that for so long that it's become the standard. I'm not particularly sure what feature sets the Oracle databases have. As far as I'm aware, at a high level, Postgres is still the most featureful and has the most things. So it doesn't mean you should use all of those features, by the way, but they're available to you if you need them. And I know that like a good number of companies, I think MySQL is actually the most popular in general, but Postgres is gaining steam, especially in the past decade or so. So yeah, Oracle, it seems like it's more of a relic, and also I'm pretty sure it's proprietary. Postgres is open source and free, and you can use it however you want for the most part. But I'm not sure that's true. Pretty much anything that comes out of Oracle, because they love to keep things proprietary. So if you want something where you kind of have control, then I would choose something like Postgres. Or if you want, if you still like MySQL, but you don't want to use Oracle's MySQL, you can use MariaDB, which is basically an open source version of it. Any other questions? I'm actually not sure what MDP is, but I can quickly mention how I'm doing this presentation. So there's actually this tool called, I actually know how it's pronounced, but I can't remember which language the word comes from, but it is a program that lets you take a markdown file and then basically turn it into a presentation. Yeah, it's a Haskell program. I may have got just an MDP when I was looking for tools like this. And then the terminal that I'm running this in is called Google Retro Term. That's actually what it's called. It's basically a terminal that makes everything look kind of retro like in this presentation. You'll notice how like there's some effects. The reason why initially it was burning in on the screen where you'd see like a little flicker, and that was kind of annoying. I had to turn that off because I forgot to turn it off. Where like sometimes when you go to the next screen, you'll see the original slide that was there before like slightly burned in. And so there's like certain effects that it has that are kind of cool to look at, but not very good for presentation. Like for example, there's this one that people are, often use if they're like trying to make it really look retro. Notice this like line that's coming through now. This is like a common effect that you'll see on like old computers. And so like there's a bunch of effects you can enable, but I turn that off because it's not, again, great for a presentation. But if you, for this, that's why my README looks kind of weird, by the way. You'll notice how like it's like one giant README and there's just some markdown syntax or like some text that I put there that doesn't look like regular markdown. That's because that's the metadata that this particular tool uses to figure out. Like for example, showing like this name here or showing this title here. That's where that comes from. Yeah, and the neon effect is also from the terminal. So let me show you really quick. I guess since we're in the last one, let me show you what it looks like if I don't do it in a terminal like that one. It looks a lot more boring, which is why I didn't do it this way. But yeah, it looks like this now in my regular terminal, the one that I used day to day. The presentation just doesn't look as cool. So I chose a cooler terminal to make everything look better or more interesting. Any other questions? And yeah, like also like I was saying, quick thing. There are of course other types of databases, MongoDB being a really popular one, and there's other NoSQL databases. I'm personally kind of biased against NoSQL databases because again, the reason that when I'm really trying to do something in production, I want the data to be as correct as I can. It can be without like, and also have like many features available to me, which a lot of the NoSQL databases typically do like one thing and they can kind of do it well, but I think Postgres can still do most of those things better and also has more features. So it's quite handy to, at least typically when you're getting started, to know that again, your data is correct more so than anything else. And yeah, it can, it is a little cumbersome to deal with migrations, but you're inevitably probably going to do migrations even if you're using like a NoSQL database because your data is going to change and the old data can't just stay that way. So either you're going to have like something that some kind of layer in between in the application that has to know every version of that data and how to change it, or you're going to run the migration. And if you don't have the built-in mechanisms to run, like for example, transactions and things like that, it's pretty dangerous. Like you might run a migration halfway through. That actually happened at like I think one of the first companies that I interned at, we were using MongoDB and we ran like a migration, I think halfway through, and it just kind of broke in production and never want to have to happen again. But yeah, it's easy to learn, by the way. I think that's how I started. So just for some context, when I first started doing web dev, I used to make fun of tools for not supporting MongoDB, and I was like, oh, they don't even support that. Like they don't like they're not in the modern web dev ecosystem. And I'm like, wow, I was so down. Like I didn't know what I was talking about. But yeah. Any other questions?
Okay, I guess if no one else has any questions, we can just end it here. Ani, thank you for hosting the workshop. That was really informational.
Thanks for having me. Excited to see what you guys make this weekend.
Yep. Thank you for helping Expo Hats.
For sure.
Okay, see you.
Thanks, guys.